reasonably large developer events, and we'll have one in March. Other than that, I'm working in a company called Nuida, so we're doing stuff related to test automation and DevOps for large customers. So you will not learn anything useful today, obviously, right? Because it's Ladcraft, it's a craftsmanship conference, it's not development or programming or anything like that. So instead, what I want to talk about is what exactly is software architecture and why should it be evolutionary? Is IT industry and software development in trouble? And can we overcome that somehow? So first question is software industry doomed? So those who have education like bachelor degree or master's degree would probably remember about professors saying that, oh, it's all doomed. They don't know how to do software because look, these beautiful engineering practices, like if you build a plane, you would have, or if you build a house, it's all different. So it's all structured, it's all using specifications, and it's all different. And software is very young industry, and nobody knows what they're doing there, right? So let's find out. So what's so different about software architecture compared, for example, to construction building, right? So so that's a typical construction process. I'm taking it as an example because I'm building a house currently, and I'm learning all the interesting details and stuff how construction industry works. It's really fascinating. So I was expecting that somebody would just build it for me, but it turns out that I have to study information on the internet and stuff like that. So like any engineering process, you would have a requirement. So build me a house, a design. Here's the design, estimate how much does it cost, and it shouldn't change, I assumed. So that's not my house, by the way. So then somebody builds it and deploys it when you move in. And surprisingly, software should follow the same process. So requirements, design, estimate, build, deploy. But nobody can get it right, right? So all the time estimates are changing. You don't know where you want to deliver. You don't know what you're building. You don't know the exact feature set of your system until the very last day. So what's the problem with that? So let's try to find out, and maybe that would be a first step of learning what evolutionary architecture is. So the first questions to answer, right? So what is design? So I picked a random quote from internet, and it says, a plan or drawing produced to show the look and function of working of a building, garment, or other object before it's built or made. I picked this one, object before it's built or made, so that's object-oriented programming, obviously. So that stuff I do know. So what's the connection here between objects and design? So if you have an analogy with the construction industry, you could represent it using this scientific matrix. So in construction, a requirement is a drawing, is a sketch. And as I learned as well, so if your house should look like this, it's not necessary that it will look like this at the end, because some of the parts couldn't be built because of physics and gravity. And, and you have to change that by engineering plans where smart people in glasses come and they say, oh, this girl doesn't know anything about physics, this wouldn't stand. And then you basically stick materials together with glue and nails, and it's all expensive, and it takes time. With software, you have specifications, which are the same drawings which a girl designer has produced. So it doesn't have anything common with reality. It wouldn't work like that, because it's either too costly or it's impossible to do with existing technologies or platform. So it's not a design, okay? Then we have code, and code falls into design. So it's exactly how your piping works, how your walls are built. So that's your code, right? So it's a specification, and then you compile and package. So that's pretty fast compared to building. And what you need is just a bit of electricity. So materials are cheap, building is very cheap, but what's very expensive in software development is designing. It takes months to build something, takes minutes to compile, and a bit of electricity. So And to continue that, what if you could build your house instantly and with just a bit of electricity? I think that this would radically change the building industry, because you wouldn't be bothering in reviewing all these drawings. You would just say, okay, build whatever you want. I'll walk in and say, please move this wall, please move this window, make it smaller, make it larger, and make me a different color of my house. And that would work fine, because it would be very cheap to replace stuff. So the majority of effort would be spent on putting a design together, a specification, which isn't that hard. So I would like to offer you a type of thinking that actually in software engineering, your design is code. There isn't any other part of it. So the rest is just drawings and preliminary descriptions of what you're building, not what the system should do. So it's probably not UML diagrams. So I'm not the one who invented this paradigm, so to say. You could follow the link and read articles from 1990s about it. And actually, the next concept, which is also relevant to construction industry, is cost of change. So when you start building something, you have all the choices in the world. So you could build it this way, that way, any color. But as you progress through implementation, you have less and less liberty of making amendments to your project, right? And some people say that that's the same with software projects, but I would say it's wrong, because it's the same both for construction projects and software projects, which have rather rigid structure and which are not intended to be changed in the future. So if you build a software system which you've never intended to change afterwards, then yes, it would be very difficult and costly to change it, especially if it's running in production. And if you have some agreements which forbid you from stopping your system in production, it will be nearly impossible to do it in an easy way. So the previous chart would be related more to a traditional architectures and a waterfall type of thinking, but we are all agile, right? So evolutionary architecture is all about minimizing the change of potential, minimizing the cost of potential changes to your system. So that's the only reason evolutionary architecture exists. But maybe there are other reasons as well. So it's not only about developers who want to write good code and try to use as many cool technologies they want to. So there are also some business reasons behind that. So every IT system has a purpose. So I've picked some examples of purposes. So number one, so firing human who previously performed some manual activity, now it's done by system. So increasing sales revenue of corporations, gathering confidential information, and other ways of helping people. So there is a business reason, and you could usually calculate that. There's a very interesting book which people in large corporations read a lot, is The Lean Enterprise. And it introduces a very interesting concept of a cost of not having a feature in the system. So, for example, if your system has 5 or 6 features altogether, and it would take 1 year to build it, so you could actually calculate how much money do you lose of not having such feature every month. So, as an example, if I don't have my advertisement, I would lose 10,000 euro every month. And if I wait for the whole system to be deployed in a year time with all 5, 6 features, I would be losing constantly this amount of money every month. So instead, let's just deliver systems gradually. So let's design an architecture in a way that it could support a minimum number of features and add them gradually over time. In this case, if you do the math, you would learn that you've actually lost less money than if you would be waiting for a year for all features to come online and then have integration problems. So that's one reason. And another is uncertainty, right? So users don't know what they want. So you don't know what users want. So that's a common thing in in all industries. So I've been asked all different questions. What type of insulation I want, what type of glue I want to be used. I don't know anything about this. So I felt like a software project customer who's being asked what type of architecture you want to have. I don't care, right? I just want features to be used and built. But to fight with this uncertainty is the only a known approach is to gather metrics. So you don't only release a portion of features or your first version of your software, you have to understand how it's being used to find out if some features do bring value and some are completely useless. Nobody ever opened this feature. And you might have heard that this old joke about 80% of features of system not being used. I wouldn't say it's 80, but maybe 30, 40 for sure, depending on the system. And if you have such data, you would actually learn quite a lot, as opposed to just delivering something with the hope that users would use it. There are also scalability reasons. So some people who fall into the trap of building a new internet startup, they assume that their system will be popular right away, which means that they have to build it on Amazon Web Services with clustering and scalability and support for 1,000 concurrent sessions. But usually nothing happens with their idea and nobody uses it. So why do we need to design our system in a way that it should be scalable? You don't have to, because so first is to prove the point that somebody wants to use your system or somebody will use your system, and then you go to scalability. First you do it in PHP, then you rewrite it in Scala. So first you go for cloud because it's easier to start up there. So you just buy some virtual machine hours, and only then you rent a room to create your bulletproof data center. So all of these reasons exist. And so when you're building something, you have to acknowledge these effects that you will have to change your system inevitably, right? So because of different reasons we've looked at, and if you're spending too much time, like several months of defining an architecture, you're already behind your schedule, because why haven't you started yesterday on PHP and on random cloud instance just to prove the point that it's useful? So that's it. So I guess that was the part trying to explain why your system have to evolve. It was a bit fast, but I think you'll get it. Now, how do we evolve the system and how do we prepare for the evolution? So that's maybe a practical part. So instead of designing and trying to predict all of the solutions and integrations up front, you could apply several approaches or patterns, and some of them are becoming really popular right now. So first of all is magical world of microservices, right? So it's now being considered as a solution to most of these problems, and of course there is a truth to that, right? So microservices is a very powerful tool if you know which end to use it. So I've stolen this picture from Martin Fowler web page. So a very quick recap on microservices. So basically, previously, a customer would commission a pretty large project with a large team, and then they would be working on producing a big box with different sorts of colorful blobs in that. And some of them would be used frequently, some of them wouldn't be used so frequently. But then if you want to scale it up, you would have to replicate these boxes with all of its contents. So you would have to replicate all of the features, even though it's only the violet one which is used extensively and other ones are not used at all. So you would lose some, and microservices, basically you're putting every feature or every subdomain, how you can call it, in a separate box, in a separate service, and then you have a flexibility on how to deploy it and scale it in the future. And it's not only about scaling, so as we'll learn a little bit later. So microservices to me is simply splitting your system into manageable and self-sufficient services, right? So there are no rules if your service has to be 10,000 lines of code, right? It could be 20,000 or it could be 20. It doesn't matter. And by manageable, well, it's also, it's not a scientific term. So manageable is something you could really understand really fast. So that's another website which you might be interested in. So Chris Richardson is gathering patterns around microservices. I really like that website. Now, I would like to jump into something completely different from a first point of view, solid principles. So who knows about solid principles? Yay, half. So, whenever professors teach you in university about the principles of object-oriented programming, they would teach you about inheritance, encapsulation, and polymorphism. So this is wrong. So these are OOP principles. So the previous ones are just object-oriented language kind of features, not principles. But principles are single responsibility principle, open-close principle, and so forth. Now, why is this OOP slide in microservices? The reason is that we could take every of such principles and do a little bit of editing. So instead of class, let's use word microservice, and it turns to be a microservice should have only a single responsibility. Sounds good? So designing microservices according to its bounded domains or subdomains. So there's a microservice for account management, a microservice for sales, a microservice for advertisement, and so on. Now, next rule. Microservices should be open for extension but closed for modification. Makes sense at all. So it means that you shouldn't get into implementation details of microservices, but rather you would be using its official APIs, whatever they are. Next, microservices in a system should be replaceable with instances of their subtypes without altering the correctness of that system. See also design and contract. It means that all microservices should have well-defined APIs, and what it means that it should be documented, it should be available for consumers, it should be stable. So you wouldn't want to change your microservice APIs all the time, knowing that there are users. And by replaceable, you would see, if you're into REST services and things like that, you would see there's a number of specifications appearing which try to converge the freedom of designing REST APIs into something more structured. Like examples, the oldest example could be AtomPub, right? So now there are even domain-specific examples. So we are currently working with something called Open Services for Lifecycle Collaboration, OSLC, where they are trying to design API, how an API of typical issue tracker or test management tool would look like. And some of the vendors are already implementing this system. So it means that you would have an API and you could replace one or another implementation because they are built according to some common standards. So that's what this rule is about. Next one, many client-specific services are better than one general-purpose service. So that's just a rule about microservices, right? So just split them according to what they do, and they wouldn't interfere with each other. And also another trait of microservices is that it's really easy to scale it over multiple teams, where one small team is responsible for one or more small microservices. One should depend upon abstractions, do not depend upon concretions. So to me, that's just don't depend and don't expose implementation details like database schema. So if you build a microservice on top of database schema, it shouldn't be visible that you're actually using MongoDB or MySQL. So it's only a REST service which you see. So that's an abstraction. So basically, microservices is treating your architecture as a set of interconnected components. And in this case, all of the rules of object-oriented programming and modularization and interactions, they apply in the same way. And you have to start thinking about services as building blocks of your architecture, not as something mandated by architects or something which will not change in the future. Oh, that's an example. So sorry. So in a monolithic system, if something bad happens, it quickly spreads. And then you cannot fight with that because even if you pour water from bucket on one box, it will still be a fire all around. Now, microservice architecture is completely different. So it creates blocks of water between blocks of mud. And then if you have a fire over here, it doesn't affect other parts of your system. So that's easy. And then you could fight with it. What does it mean? It means that it's easier to do risk management with microservices. So since they are isolated, and it's not so easy to do because when you're building your architecture, you have to assume that most of the microservices are optional, so they could go down. And if they go down, you have to figure out what to do. So either you report an error to user saying, sorry, you could still play around in this service, but you cannot do any financial processing. Or you consume data from cache, which you've gathered previously when this system was online. And another interesting thing is that in microservices, I wouldn't be so concerned about code quality because it's easy to get rid of this microservice in the future if it becomes nasty. Yeah, but if it has good quality, why did you spend so much time on it? So if your microservices are really small, don't bother, right? So what matters is your API tests, which tests this API, and interactions between services. If the code is great, well, fine. Then we can get rid of this temporary service. Well, of course, I don't encourage you to write bad code because everyone writes good code anyway. And another thing, design mistakes. Okay, you could play with new NoSQL technology. Yeah, and then your mistake of playing with NoSQL technology wouldn't spread to all of your system. However, I think in most of realistic microservice projects, you would still have one platform. It's just this platform would be a set of reusable practices and libraries as opposed to encoded in one monolithic code base. So that's risk management. Communication. Microservices should communicate with well-defined APIs. Event-based architectures are very, very relevant because if you have multiple services, if you would start building end-to-end integrations, you would end up in quite a mess. So usually, when you outgrow your first system releases, you would need to come to an event-based architecture, and you should be able also to apply some topology configuration changes on a running system. So, for example, bring some module down or add some more instances of this module if you feel that the load is too high. So basically, microservices is the same as service-oriented architecture, but with no rules. So you wouldn't have any SOAP or WSDL standards. So, but the concept is the same. So the concept of service registry was there 15 years ago. It's just now you could pick any service registry, and previously you would have to use SOAP and WSDL. So yeah, I think you could wipe off the dust of SOA books and read them, and just in your mind replace SOA with microservices, and it would all be fine. Another concept which is really relevant to evolutionary architecture is Containers. So what type of containers? So again, stole this picture. So a container is a relatively new type of virtualization. And the big difference between virtual machines and containers is that they are reusing host OS kernel. Basically, I don't know much about Linux, so please forgive me if I'm not correct. But so basically, every virtual machine is a separate operating system, which is a little bit. It takes some time to start it. It consumes more memory. With containers like Docker, you could have a lot more virtual machines on one host OS. But that's not the only benefit. So that's technical benefits. Okay, I will consume 1 GB less of RAM. Who cares? Now let's get into practical stuff, and these are conversations from my experience. So when you are talking to your system administrator, who is responsible for making sure your system runs, so you would be asking, can I change this setting in Apache web server? No, because I don't understand what it is. So can you install the latest Java? No, because it didn't pass security audit. Can I upgrade Linux kernel because my library wouldn't accept it? No, because it's too risky. And of course, can I get sudo access? Of course not. But reality is, so system administrators are afraid of you and they don't know what they're doing. Okay, they keep operating systems running. That's fine, and let's give a credit to them. They're great guys, but they don't know what's running on the systems. They don't have a clue, and that's why all of these answers is no, no, and no. But what changes with containers and Docker specifically? You have a completely different discussions. You're saying, hey, I have a new container image, please deploy it and make sure it's running, and please also ensure that you have 25 of these instances. An administrator would say, okay, I don't know what it is, I just run it and make sure it's running. Because it's an isolated virtual machine, it cannot, or at least it shouldn't, come out of container and steal the root access, hopefully. And that changes all of the dynamics between the developers and operations. So you just supply containers, and the container could be any distribution of Linux with any third-party libraries, with your settings, with your rules. Great. And that becomes much easier to manage and evolve in the future. And guess what? Solid principles are relevant to containers as well. So when you design your containers, you could either put database and Java together, or you could create database and Java as separate containers. And that leads us of thinking that single responsibility principle is also applicable in Docker. It's possible to extend containers. So you could have base containers, and you extend, and then you extend again, again, and again. So you have to think about hierarchy of containers. And what would container interfaces, APIs would be? In Docker, there are at least 3. These are possible environment parameters, shared folders, and inter-container links. So this is an API of a container you have to design as things through. So there are lots of decisions to be taken in container space in order to make it manageable and possible to evolve further. So in my view, container technology is really relevant to evolutionary architecture and would allow you to make changes to the system while you develop, because it helps you to decouple your architectural component, but still running on, say, one large piece of hardware. And it's supporting DevOps model, where you would have a close collaboration between operations and developers, and you can do changes in a rather agile way and automate everything. Speaking about automation, now, what can we tell about test automation? Number one, it increases testing costs. So you all know that, right? Test automation increases testing costs. No, it's not. we, we are participating in largest test automation projects in the world. It definitely increases testing costs. And the reason is that hiring manual testers is very cheap. And you don't need much infrastructure either, or licenses, or anything. But what it does, it decreases feedback cycles. So instead of waiting for a month or two with your team of 20 manual testers to come up with results, you could just rerun your tests in a day or in an hour, but most likely a bit longer, and get a feeling of how your system behaves. So test automation isn't about cutting costs for testing, it's about decreasing feedback cycles. And when your team of manual testers went doing their job for a month, you don't know what's happening with your system, so it could be dead. And developers are still adding some code to it, not knowing that it doesn't work at all. So that's the biggest value of test automation, that you would say, stop, don't do it, let's fix it, and then continue our work. And what's interesting, you all remember the famous testing pyramid with unit, integration, and functional test. So this pyramid is here. Now on top of this pyramid, there's another pyramid. So you would have to do a microservice level functional testing. You would have to do microservice integration functional testing. And you would have to do end-to-end system functional testing consisting of microservices. So now we have two pyramids. But you can't get away with it, because instead of monolithic system of one box, you now have a set of interacting systems, and you have to design your test strategy according to these new challenges. So this is a really good article about the subject. And evolutionary development is not possible without test automation, because it's too many moving parts. You cannot predict what will break and where. So without decent test coverage, it's simply not possible. Databases. That's an interesting topic. So everyone remembers these DBAs who are responsible to keep a database schema intact. All changes should be authorized. Database has its own life, lots of PL/SQL or TSQL or whatever SQL scripts, which only few people can modify. So now we are abstracting databases with APIs, and it's more treated like a storage. So databases are now picked not because they have some particular functionality, but because of what is your type of data you want to store. Is it dynamic? Then it's probably something like MongoDB. If it's structured and you have to normalize it, then it's still SQL, because it's not given that NoSQL is better of SQL in general sense. It's just these databases have a different purpose. Most of the logic is in service layer and doesn't depend on database. And that's why it's relatively easy to swap one database to another, because details are not exposed to your APIs and further to your subsystems. So to recap about all of this, so individual developer responsibility is constantly changing, and so the industry brings you more challenges. If previously you were responsible for object-oriented design and designing your interfaces and classes in Java or .NET, now you have to know the deployment platform, prepare containers for DevOps people to run, and think through all of your APIs, which is another layer. So you have object-oriented APIs, and then you have RESTful APIs and event-driven APIs. So it's more things to learn. Yay. And that's a different challenge for architects as well. I wouldn't say that architects are useless, because it was on my business card for years. but basically, there's still a space for architects, right? But they have to be hands-on. So they have to understand how technology works and help to evolve the code. And code is design. So they are designing a system with code. So they might be working on reusable components, on REST APIs, on some critical pieces. And also, a distinguishing role of architects is keeping everything together in his head. So to know the overall direction where the system is going and what are its boundaries and what problems you want to work around. But nowadays, if you see someone handling you a bunch of UML diagrams, that's a sign of a real problem. Especially if it's some sensitive stuff like database schema, because database schema has to be suffered through. So you won't understand what your database schema should look like unless you write a bunch of automation tests and prove that it's really working, not using paper and pen. So evolutionary architecture helps you decrease cost of change, feedback cycle loops, but also significantly increase your solution complexity. So that's what Martin Fowler was writing. So he released this article, hey people, let's do microservices. So everybody went doing microservices. And he was shocked. He had to write another article saying, don't do it. Do monolithic architecture first, and only then you go to microservices if you're this high. Yeah, and that remains true. So the tooling isn't completely there yet. You'll have to make your own decisions, your own prototypes. It's only starting. Recurring patterns, solid principles are everywhere. Well-defined APIs, database agnostic, platforms, Dockers, so on. And the question, how to find a balance between upfront and evolutionary architecture? Well, you don't. There are no rules, right? So it only comes with experience, and you have to call craftsmen for help. Because there's nobody in the world who could do it other than them. That's it. We have time for questions, for 3 questions. I understand if you don't have questions. Oh, please.
I was wondering about the microservices. To not have one of them bring down the whole system, first of all, if they can't depend on each other. But also, if you're building an application from scratch, the responsibility of a single microservice could possibly change as you're developing. And then at that point, how do you kind of deal with legacy code and evolving?
So the question is, in microservice architecture, you start with thinking that this service should do this thing, but actually you have to split it afterwards or change it a little bit. How do you deal with legacy code which was written yesterday? By the way, all of the code is legacy, right? You know that. So only today's code isn't legacy. So again, there isn't any answer. So you have to have a bright architect or technical lead who can foresee these changes and refactor and make it beautiful. And also, of course, you shouldn't make all of your microservice APIs as external ones. So some of those could be internal ones, and you could change them whenever you like. So they shouldn't be stable. So yeah, and that's fine. So I guess that would be the answer. Question number 2. Please.
You said that UML diagrams are a sign of evil. However, how much documentation then there should or shouldn't be?
Okay.
What's your criteria for documenting something?
So my criteria for evil. UML diagrams are not evil. I wrote a bachelor thesis about them. But the evil is that people assume UML diagrams as a design which cannot be broken. Kind of when you code and look at UML diagram and do exactly like it says. So that's evil, right? Because how do you know that it's been written correctly? So UML is a great tool to draw stuff on the whiteboard or to send someone a diagram. So you have to learn it, but it's not a core artifact of your architecture. So you've drawn a diagram. After a month, you could throw it out because it's most probably not true anymore. So UML is a communication tool, and for requirements, I guess it's different from project to project, and also different from who is your customer. Because if your customer is not technical, you would have to come up with some sort of non-technical documentation of requirements. So how would you handle your work if you don't have any requirements? But if you're happy to work with technical customers, then maybe you don't need so many documents. It depends. So the last question, yeah.
One of the agendas of your lecture was something about how to define the languages, frameworks, technology, something about how to start from it, how to start the project. And according to your lecture, saying that you can't start with microservices, start with monolithic, but then you go to microservices, but sometimes you can't split your monolithic application because nobody gives you time to do it because everybody needs more features and you can't simply throw half of your code just...
Yeah. So
maybe any advice?
I guess the question is, how do you start with microservices if you already have a monolithic system? Maybe you don't, because it's too late. And the business wouldn't be satisfied with taking 3 months of refactoring. These are the same types of questions, right? Which you cannot answer just like that. So from one point of view, you could start with monoliths and split it later, but from another point of view, there's a point of no return where you would have to rewrite your system, and it would be cheaper to rewrite your system rather than splitting it. And I've seen such cases when you would have senior developers banging their heads and not being able to refactor anything. So yeah, but at the same time, you could start building a monolith with modularization in mind, that you would be splitting it further down the road. So I guess it wasn't helpful, but at least that's something. All right, thank you.